Right, welcome back to this next video. So in this one we're going to be having a look at gradient mapping. So what is gradient mapping? Well, I have here a texture gradient created in Photoshop, just black to white, well, with a little bit of yellows and oranges and reds. I've called this a fire gradient. You can definitely see how the colours of a fire are contained within this. And notably, I've clamped my edges. I'm just going to disable that for a second so you can see the error you get. But we have imported a texture gradient. Now this is 1024 by 64. It's pretty big for a gradient. It doesn't need to be as big as this, but it's also quite small compared to a kind of texture in itself. So yeah, you can import your gradients. And what we want to do is we want to apply a color gradient, this color gradient, to our texture. So I have here the Fire flipbook that comes with the engine, and what's happening here is it's black and white values, and each frame is a next frame in an animation, and the idea is this plays back and forth, and you get, or plays forwards, and you get a sort of fire animation. But notably it's black and white, and so we want to colorize this, and we could just multiply by a color. If I go back to my material, take this, take one of the channels, multiply by a color. And if I pick a nice kind of reddy, yellowy, orangey color, something like that, we get color. It's colorized our texture, but it's done it in a very flat way. Every part of that flame is now the same color. It doesn't look very good. Not the best approach. Instead, what we want to do is we want to use our color gradient. And effectively, all we have to do is take our black and white texture and plug it in to our UVs. So if we plug in this one, black and white UVs, gradient, black, black, or 0, 0 top left, 1, 1 bottom right, what it will do, it will take our texture and just display it correctly. But if we use our grayscale texture image here, we have black. So everywhere this is black, it's going to display the top left pixel, which is also black. Anywhere it's white, it's going to display the bottom right pixel, which is in this case also white. But all those grayscales are going to create kind of like a diagonal line through our texture gradient. And if I do that, you see we get that gradient mapping applying. Now this is the error from clamping. What it's done, well, it's taken the 0 and instead of displaying black, it's displayed white. So we just need to make sure that our edge pixels are clamped. So effectively, rather than displaying up here, it was displaying down here, and we were getting that horrible border. If I just go in and go back to our material, you may need to refresh this after you make that change, if you make that change. And what we can see now is those colors in our gradient have been applied to our material in a much nicer way, and so we're able to get color depth. And the really powerful thing about this is this gradient doesn't need to just be fire. We could use dark magic. So here it's purples and oranges, purples and blues and reds. And so by changing the gradient, we can very quickly change the appearance of our result. And we're able to reuse the same sort of animation flipbook with different gradients to get different results very, very quickly. And there is a great example from Halo. If I can find it. Here we are. I was just talking about gradient mapping in League of Legends as well. But if you can see, if I zoom in on this a little bit, oh, it's a whole breakdown here, but specifically this image. The Halo muzzle flashes were only able to use a single sprite. I think this is Halo 1. But rather than having just different kind of colors, they were able to take a gradient texture and then remap their sort of smoky sprite to get different results for the different weapons. So the different colors coming through, and you can see here the sort of fiery shotgun, and they look very different. You wouldn't notice it was the same sprite. And you can even do some quite funky effects here where the white point isn't necessarily at the end. So we get this kind of like nice white line where it then goes back to black. And so this technique is used all the time in games because it's a really powerful way to get multiple color sort of results out of a single texture. And anytime you can reuse things, obviously is really optimal. and good for games in real time. Cool. So that's gradient mapping. It's very simple. You just take your black and white texture, plug it into your gradient texture, as long as the edge pixels are clamped. But we can also do it using in-engine curves. So this is let's plug in the result. So this is a in-engine defined curve rather than a imported curve. It gives us a little bit more control and is a bit more optimal because we're not bringing in textures, even though they're not very big textures for gradients. We can do it here instead. And the way we do this, if I go to my gradients, if we right click, create materials, nope, it's a blueprint, no, miscellaneous, it's a curve. So we can create a curve. We're going to create a linear color curve, and that becomes a new asset. So we're just going to call it new curve. We can define our colors, and let's say just have a midpoint color. That's the opacity. I want the color curve. Choose color. So I'm just going to go from black to white to blue, something like that. And we can spend as long as we like defining our curve in here. With all the tools that Epix have provided, and then in what we then need is a color atlas, or a curve atlas. So miscellaneous curve atlas. In our curve atlas, we can assign the different curves, so gradient curves, and we can plug in our new curve. And we can have as many curves as we like in our atlas. Let's do this. So you can have an atlas that was all fires, or one that was all magic related, that kind of thing. And you can see what it's doing is it's just putting those curves up here at the top. It's just assigning them one by one. So I probably don't want the square. I can do this and make it 16 or as many curves as we have. Probably still wants to be a power of 2, to be honest. But a 256 by 16 is very simple, very small texture. And then in our material, we create a curve atlas row parameter. We can call it whatever we like, curve, and assign both the atlas and then which curve we want to use within that atlas. And there we are. And it's simple as that. We're now using an in-engine curve to do our colorization. One thing to note, when you're plugging into your UVs, I'm using a single scalar value here, so I wouldn't want to plug in RGB. I would get an error. You can't use RGB to plug into UV. So in this case, we're using a single value. I think if I append this to UV, it's going to give me an error as well, isn't it? Yes. So in this case, we're using the inbuilt curves. We just want to plug in a single value. Here, we'll be plugging in the texture. This is looking for a 2 input. So what that's actually doing is replacing the float value here, the scalar value, with a vector 2 with that value in both. And so effectively, oops, if I can zoom in any further, there we go. Effectively on our gradient, we're getting top left down to bottom right. So this diagonal is where we're sampling our pixels, because we're plugging in 0, we're getting 0, 0. If you plug in 0.5, we get 0.5, 0.5, etc., etc. Now what we can do, I don't think I did an example of this, no, is you can potentially create a gradient or an animated gradient. So you could have one gradient at the top line of pixels, one gradient at the bottom line of pixels, and transitions between them. And if we just append a constant, if I make this say 0.01 rather than 0, now we're reading that top line of pixels because our U value is constant. And if we change this value, we could read the next line of pixels. So you could pack multiple gradients into a single texture, effectively like they're doing here, and then sample a different Y value and change your gradient over time, if you so wished, taking that to a next level animated color gradient. Okay, one last example here. Well, Another advantage of doing this is we get full control of our texture before we colorize it, before we access that. So if I just plug this one in, effectively, anytime we want to edit a black and white mask, if we have these three nodes in order, add, power, and multiply, and then clamp, I guess 4 nodes, we can get full control over what our texture is doing. So let's say we wanted to reduce the sort of intensity of our fire. If we add a small negative offset, we can kind of remove some of the grayer values. If I have a look here, what's happening, we're reducing the values, bringing it down minus 0.5, that kind of thing. And now our maximum value here is 0.5, but if we multiply by 2, or possibly even 4, let's actually preview that. Now we're bringing back up the intensity, and we'll get a sort of different look to our fire, but the colorization is happening at the end. We can also do this by adjusting the contrast, bringing that in or reducing that up. But because we're doing it before it's colorized, it's then able to then be colorized at the end, and we're not getting any kind of like changes to the color. If you try and power a colored texture, you end up with incorrect color happening. And so where this is nice is you can do all of this stuff as a sort of particle thing. Obviously this is a flipbook, it's kind of designed to be a particle, and so we can animate and affect our black and white mask before we colorize, and then if we do want things to be brighter, we can always multiply by an intensity at the end. So a lot of control. And then obviously if we want to just change the look of that, we can quickly do that and just change the color curve as well. So very powerful technique, used a lot in particle systems. There are some applications for environment work as well. If you have a black and white texture, you can do a gradient mapping. Good example on Polycount here of using gradients and then color curves. So here, for example, a wood can have different values based on, or different appearances based on using just a simple color curve and a black and white input. So might be useful for your environments as well, but very, very popular or very, very powerful thing that we use in VFX. Okay.